My name is Brent Nelson. I'm in the Building Technologies Office at Department of Energy, and I am also a lifeguard. My talk's going to be a little bit different. Rather than talk about what I actually work on, I'm going to talk about why I work on what I work on. So what you see here are a lot of pictures of different fuel sources: nuclear, oil, coal, natural gas, solar, wind, geothermal, hydroelectric, as well as biomass. And this graph shows kind of where all those energy flows go. And the thing that you should really notice here is that if you look at coal, natural gas, and petroleum, those are the big stripes. That's where most of our energy is used. And everything else, which is the carbon-free stuff, are all these really little stripes. And so when we start talking about how we're going to move to a more sustainable, renewable energy future, we have a lot of ground to make up. And as we think about making up that ground, the thing that we need to remember is that the reason that those are such big stripes is that they work really, really well. You might think that you don't like big oil, but the reality is you do, because it's really convenient and it does a really good job. Because if you like to travel internationally, if you like to go on road trips, if you like having fresh produce in the winter in DC, if you like Apple products and you don't want to live at the Apple factory, you like big oil. And the reason that big oil works so well is that portability is a major challenge. If you've ever car camped versus backpacked, you know that when you go backpacking, things like size and weight matter a lot. And the graph below shows sort of size and weight as a function of how much energy fits in those size and weights. And what you see is that diesel and gasoline work really, really well and pack a lot of energy, and batteries and hydrogen don't do so well. And when you start moving to the electrical grid instead of transportation, timing starts to really matter as well, because we want to flip a switch and have the power come when we flip the switch. We don't want to have all our energy at once and then have no energy for forever. And it's the same thing when we eat. We want to eat when we're hungry and not eat when we're not hungry. And so as a result of that, you start thinking about how units of energy aren't really equal. 1 megawatt hour is not equal to 1 megawatt hour, because when that megawatt hour comes is really important. Power is important. Power involves time. And the cost of energy is very different at different times of day. And we want to be able to dispatch power when we need it, and we can't really do that with the sun and the wind because they don't listen to us and they don't care. And that hasn't even asked the question yet of, can we even afford this and does it pay off? And the question of does it pay off isn't really a simple question anyway, because the real question is, does it pay off fast enough? Because we don't have an unlimited pot of money. And if I have an amount of money that I can either pay off in a year or pay off in 10 years, I'm going to invest in the thing that pays off in 1 year. And so you have to think not just is it affordable, but is it affordable over the time scale that we need to afford it? And so as a result of all this, I don't want to say that we should just not care and we should burn everything and burn it all to the ground because it just doesn't matter, and we should just, have as much carbon emissions as we want. But there are two big lessons that, for me, come out of this whole context. And the first big lesson is that we shouldn't pass the blame. As much as we want to demonize everybody else, the reality is that we all like big oil and we all like fossil fuels because they work really well for what we want them to do. And we need to recognize the roles that we play in that. And because we play a big role in that, because these things afford to us opportunities that we really like to have, the real important question is, how do we solve the problem? Right? If phase 1 is we want to save the planet, and phase 3 is the planet is saved, the real question is, what's phase 2? And this is what I get excited about, and this is what we work on in Department of Energy, is all the stuff that's going to be that phase 2, all the stuff that we need to develop, the technologies we need to produce, and everything we need to do in order to get to that point of solving our energy issues. So, thank you.